So this is a visual representation of the demo. We have the TM500 on one side. We have the RDA running the data applications. We have the CMX500 running the channel as well as the network. And they're all connected together in the lab by a switch, a layer 2 switch, and controlled by a single PC. And all that together emulates the NTN geo scenario. What can we do extra with this setup? We can set up a proper digital twin end-to-end system where you have a UE talking to another UE going through a full network. So in this case, you see two TM500s acting as one endpoint for UE1 and another TM500 acting as the other endpoint for UE2. And we go through the CMX500, which acts as the network, emulating both the RAN network and the channel. All that data goes into an IP network as usual, and then can be fed out again to a second CMX, and that CMX routes it back to the second UE. We can drive all of this with our real data applications, so you can even do voice applications where one UE is speaking to another UE over NTN links. You can also modify that scenario to do one link could be NTN and the other link could be non-NTN. So giving you a full end-to-end system for characterizing and evaluating NTN scenarios fully. So now we'll go and show you the testbed. So the CMX has started, and once it's ready to use, we'll see it turn green on the left. So it's applying the configuration now, and after it finishes applying the configurations, we'll look at all the settings on the right-hand side. So now the CMX is ready to go. These are all the settings on the right-hand side, from the peer element settings, the security settings, all the way to the UE assistance information, UE capability, as well as measurements, and down to even the message logging and the test mode. So you can set everything that you need, as well as the 3GPP parameters. So on the 3GPP parameters, you can go all the way down from the frequency and the band that is used, the bandwidth part configuration, the core sets, all the way up the stack, physical channels, as well as layer 2 for the HARC and the paging and the cell behavior. So now that the CMX has started, it's ready to accept connections from a UE. So we need to move over to the TM500 side and start the test there. So here the test has been set up for an NTN geo scenario at 75 east elevation. So all we need to do is to start the test here with the play button. And while that is starting up, the TM500 GUI has the ability to configure all the different aspects of a UE. So from the roots of the UE to where it's located, and we'll see that for NTN, we have to put that in either ECF or longitude and latitude. So when you look at the route, you see that we can configure it either in ECF XYZ positions or in the longitude and latitude option, which is the longitude, latitude, and altitude. The other settings that you can do on the UE to do its mobility scenarios, in this particular demo, it's fixed at one location. We can also set the data traffic profiles. In this demo, TM500 is closely integrated with the RDA, real data applications from the Terra VM. And that way, any type of data flow you want created can be synced with the TM500 exactly. So we have in this case, TerraFlow for the downlink and TerraFlow for the uplink. And then now we see that the test is running. On the right-hand side, we decode the MIB on the right, and we can decode the SIB1. And in the SIB, you can see that this is an NTN carrier. We also decode the SIB19 which tells us about the satellite parameters. So we can see the satellite ephemeris in the XYZ positions using ECEF. And we can tell that this is a geo because the velocity of the satellite is all 0. Now we can see that the UE has progressed and has attached to the network. And you can see on the right-hand side here all the messages and the sequence of those messages to attach the UE to the network all the way to attach complete. So moving over to the GUI from the TM500, we can see this is where we configure the test steps. We can also see the cell power in our CellWatch GUI. We can see the SSB power as well, which is we are logging in real time. We can also see the stats in the physical layer for the downlink shared. We can see the stats in the physical layer for the uplink. And we see a system overview that tells us what is happening in both the downlink and the uplink, as well as the PDCP layer for layer 2. Moving down to this section here, if you go back to the top, when this test started, you could see that the UE found the cell, tried to connect to the cell, and then sent its random access and completed its random access procedure, signifying a complete connection to the cell. After that, it needs to go through the other steps to register onto the network. And we can see that the registration was successful at the bottom here with the PDU session and the data network being assigned from the Rohde Schwarz CMX 500 with a valid IP address. And the registration result is 3GPP access only. After that, we automatically open the data channels using the TerraVM RDA, and you can see that the applications that we configured for that UE in both the uplink and the downlink have been started. And that also is resulting in the throughput seen in the throughput graphs above. Crucially, for NTN, we have added the measurements for delay as well as the distance and the Doppler. For a geo case, the Doppler is 0. For the delay, we see that the single link delay from the UE to the satellite, emulated satellite, is 256 milliseconds. So we see that the distance is roughly 36,000 kilometers above the Earth's surface, which is the valid distance for a geo satellite. So the other KPIs you can get from the TM500, you can run commands as the test is running. So this is our get stats command. And when we issue it, we get a print of all the statistics from all the different layers. So we can see the physical layer as well, which we saw in the GUI. But crucially, we can now see all the 32 HARC processes that are valid for an NTN scenario. So going down from HARC process 0 past 16, which is the default for NR, and all the way down to 32. So this 32nd HARC process, which is new to NR-NTN. We also see that in the uplink as well, all the HARC processes from 0 to 31, so which is the 32nd HARC process. We can also see the MAC stats, and we can see the RLC stats as well as the PDCP stats to the top of layer 2. The other one we can get is the layer 3 statistics. So we get RLC stats, and it's printed, and we can see that there was one UE connected, and we can see all the KPIs associated with that UE. We can also get it for NAS, and we can see the NR registration count, which is one UE in this demo, as well as all the other events for that NAS, for the NAS layer on that UE. So showing that you can connect in the lab to an NTN system using the TM500 as a UE emulator, the RDA as a data source, and the CMX500 as an emulated G-Node B, as well as emulating the NTN channel. And as we saw, the delays and the distances that the UV observed from that setup. The NTN digital twin offers true end-to-end performance evaluation under a variety of conditions and configurations, all with the lowest footprint in the market. Benefit from the collective talent and expertise of the two world's leading test and measurement companies, a single point of contact to access a wealth of resources. The NTN digital twin from VIAVI and Rohde Schwarz, the best of both worlds.